Hello, everyone. I think we have enough participants now and we can begin. Please confirm that you can hear me clearly.
Confirmed.
Yes,
Oh,
yeah.
okay. Hopefully, others can join us when they are available, but we don't have to wait this long so that we will be able to cover enough within the time that we have. So before we begin, I would like think there are a few names that I know here. I'll just pick one of you to open us in prayer. Um, okay, Esther, please pray for us.
Okay, let's pray. Thank you, Father, for your grace and opportunity such as this. Thank you for bringing us from our various activities today down here. Thank you for today. Thank you for your mercy which you showed us today. Father, we pray for forgiveness of sin. Forgive us in any way we've erred during our course of activities today. And we pray, O Lord, committing our facilitator into your mighty hands. Give him the enablement, give him the strength to be able to explain to us more. Help us, O Lord, give us wisdom, understanding, retentive memory to understand. Thank you, Father, for answering our prayers. Thank you because we know that we will be able to achieve more than we expect this evening. We pray in Jesus' name. Amen.
Amen. Thank you very much. Once again, you are all welcome. Please, I'd like to plead that you keep your mics muted except when you need to speak. And when you want to say something, kindly use the hand emoji to raise your hand so that I can um, call you to speak so that we will not have a distracted moment. Also, some of us have weighed the emotions in the air, and I realized that some of us have a phobia for numbers. Once we see numbers and some of the symbols that have been introduced in statistics, we get scared. So I just want to clear the air to tell you that you don't need to be afraid of those numbers. If you have the courage, give yourself a pat in the back that you can do this, you can. And this meeting is to enable all of us, you know, go through this process successfully, write our exams and pass. So if you are here and you have some form of fear about statistics and all that it entails, please just take the fears away from you. Believe that you can do it. By God's grace, I will try as much as possible to start from the very basics and we will grow in momentum from there. All right. Having said that, I will show you my screen. My first question would be, have we all downloaded the materials that we have in the second link? Do we all have those materials now?
Yes, the ones that are accessible.
All of
Is there a second link?
Yes, there's a second link in the email. The link that says GDS resources is a link to a Google Drive where I've placed all the necessary materials we will be needing, including the practice questions that Professor Babalola posted. So please, if you don't have that, kindly click on that link. I think let me open that link on my browser and see if I can show you what you have there. I'm trying to look for it now. Okay, this is the email. Can you see my screen, please? Someone,
Yes.
okay, so this is this link, this second link is where you have access to the resource materials that I posted. And if there's any other additional material I will drop, it will also go to the same link. I'm trying to open my drive to see if I can show you the exact folder. Okay, so once you open that link, you should see a folder like the one you can see on my screen. And if you look through, you see that most of the things I have dropped here are items you already have, which were shared by our lecturer. But I intentionally dropped them here so that we can have a uniform place to assess most of these things. Okay. But then for a class we are having, open this particular folder that says practice question solution starting point. Okay. You need to download this Excel file starting point. Everything we'll be discussing, we'll be using this Excel file. So my demonstrations, you'll be able to implement using this starting point Excel file. It already has some content, but limited to the point where we can start from. Then as soon as I begin demonstrations, you can start doing exactly the same thing as I'm showing on the screen. So please download this Excel file. That's where we'll be starting from. Thank you. Once you download that Excel file, you have a similar page as the one I am displaying now, but may not have as many tabs as this or sheets as this one, but what you have should be sufficient for our discussion. And what we want to do, or I intend to do, is this. This meeting is not for me to solve the practice questions for each of us so that we can do copy and paste. If we follow that process, we may not be able to achieve the goal for this meeting. So what I have done is to prepare questions that are similar to what we have in the practice question. The structure, the data outlook looks similar, but not exact data points. Okay, so I'm going to open the practice question that has a similar question as this one you can see on screen so that you understand what I'm talking about. The goal is for you to follow the procedures we'll be demonstrating to solve this question yourself so that you can be able to replicate the same during exam. I hope we all understand what I'm trying to explain.
Yes.
Okay. So if you look at this practice question, this is the one from Professor Babalola. You notice that we have t-test and then you have proficiency score of, okay, let me just read it out. Proficiency scores of two groups of library users are given below. You are required to compare the average scores for the two groups of respondents. Construct a suitable null hypothesis and use the t-table to test the hypothesis at 95% confidence interval. And here we have 12 entries. That is 12 different participants per group. Okay. So this is the question we'll be starting with. And when we are done with this question, we will go on to the next one. I'll be pausing at some points to admit people that wants to join. So in case I pause, just know that I'm trying to admit someone. Okay, so now if you look at the structure of this question, practice question we'll be using, you see that it's in the same format as the one given to us by Professor Babalola. So once we're able to tackle this question and successfully solve it, you can use the same procedure to solve Professor Babalola's question. You notice that this question says the performance scores for two groups of pupils are given below. You are required to compare the average scores of each of the pupils, construct a suitable null hypothesis, and use the t-test to test the hypothesis at 95% confidence interval. The same structure. And if you look at the numbering, the same set of numbers, but not exact numbers. And then here we have 15 participants per group. In Prof's question, we have 12 participants per group. So the goal is to use this my redefined set of numbers to illustrate how to tackle the problem. Then you can now solve the problem using the same approach so that we will not have to copy each other's um, output or data, and then our answers will look similar. At the end of the day, we are going to have the same answers, but some of us may do approximations at some point, others may not. So that will make our approaches to be a bit different, so that but at the end of the day, we're able to achieve the same goal. Are you with me on this, please?
Yes.
All right.
Yes.
All right. So let's go in and begin with our solution. But then another thing I want you to understand, like Prof explained in class, statistical analysis, or most of them, hovers around measures of central tendency, that is mean, median, mode. So we'll begin from the very basic by getting our mean for this question, explain how the mean is relevant in answering this question, and then we grow from there. So just open the second sheet, that is practice question 2, question 1. Once you open it, you have a similar page as what I have here. What I have simply done is to transfer the data from these two columns into X1 and X2. If you open your second sheet, you will see something similar to that. And please, if at any point you feel confused with what I'm trying to explain, call my attention and I'll repeat and explain again. So what we are trying to solve here is a t-test, because we are comparing the means of two different groups. And the formula for t-test is this. Okay. And here you can see that we have the mean of group 1 minus the mean of group 2. One of the challenges people have in statistics is when they see formulas like this, they get scared. But I want to encourage you not to be scared of numbers or formulas. Formulas just help us to arrive or tackle our problem stage by stage. If you look at the numerator part of this formula, you see that this symbol represents mean, that is X bar represents mean. This other X bar represents another mean, because we have two sets of data. So the first thing we'll be solving is to find the mean for each of these groups of data. Okay. On the other side of the formula, the denominator, you have two labels. The first one on top here, where my mouse is pointing, is the variance, while the N represents the number of observations. That is, when you count the number of entries here, how many are they? That's what N represents. Then the S raised to power 2 is variance. So basically what we are doing here is to solve for our mean, variance, basically mean and variance. And once we're able to solve for our means and variances for the two groups, we plot it into this formula and we have our answer. Now, another thing we need to clarify is that the mean we have here is the arithmetic mean, because here we just have individual values, not a group of values with frequency occurrences. So this is the arithmetic mean, where we just add up all these values one by one and divide it by the number of occurrence, the number of observation. Are you following, please?
Okay, I have a question.
Yes, go ahead, please.
Okay, so I overheard you mentioning that yes, is variance. Is variance same thing with the standard deviation?
Variance has a very close relationship with standard deviation. Okay, variance is the value that we get by squaring deviation from mean. Is the value that we get from squaring deviation from mean. That is why you have S square. We are squaring deviation from mean. And you will soon see what I mean by deviation from mean once I begin to, illustrate the analysis. Okay, so that's what you get. That's what your variance, the summation of the deviation from mean squared. But then to now get our standard deviation, you just do a square root of your standard of your variance becomes the standard deviation. Do you understand?
Yes.
Once you do a square root of the variance, you get the standard deviation. So when you have a standard deviation like this, if you square the standard deviation, it returns back to become a variance. Then if you take the square root of the variance, it becomes standard deviation. Okay. I'm still admitting people. More people are joining now. So the first thing we do is to calculate the mean and to now evaluate variance, which will take us to evaluating standard deviation. We need to also do the deviation from mean and then the square of that deviation. If you look at this table, you see that I have what I labeled here as D. I have marked something on this column of the table. I marked something here, marked something else here. Once I unmark these things, you will see what deviation from the mean is represented as D for now, and then this square here for now. But once I unmark this, you will see what that is. Okay, so we first need to calculate our mean, but to get the variance and standard deviation, then we'll begin to evaluate our deviation from mean and then the deviation squared, the summation of that deviation, that is uh, uh, addition of all the values derived from the deviation, that's summation of deviation, which will now give us our variance. But we'll continue as soon as we move on, you will see the breakdown of these processes. Okay. So let's begin by trying to evaluate our mean. And how do we get our mean? Like I mentioned, it's simply addition of all these values together divided by the number of occurrences. Okay. So let's begin from here. So we need to find out how many occurrences do we have here?
One.
Number of observations. If you count it, you will say 15. But to help us, this meeting, we will be understanding how to use Excel at the same time as solving our problem. Okay, so to get the number of observation, I'll just click in this open cell, do equal to, and then call the count function. Count, click on this first cell, drag to the last one, and then close the bracket. That will count the number of items in that range. So I expect that you should do the same. Once I hit the enter key on my keyboard, you will see the number of observation, which is 15. So now I hit the enter key and we have 15. So our n, we have been able to solve for our n, both for the first group and the second group. N is 15. That is solved. Okay. Then the next thing we need to do is to do this, the add up of this. The entire items here, add them up, which is why I have developed this summation of X. And I need to take time to explain this symbol, sigma, because most of us get scared once we begin to see these symbols. Whenever you see symbol like this, It's called sigma. And what does it mean? It means addition. Add up all the values of X label X. Add up all the values of X. And what are the values we have for X? These are the values of X. So this symbol means add up all these values. This plus this plus this till you get to the last item. Normally you call it summation, sum. That is add up, which is exactly what we are going to do. So we use the equal sign and we use the sum function in Excel, SUM, open bracket, click and drag this range, close bracket. So you can see what we're just doing is to sum it up, to add all this together. Once I click, press the enter key on my keyboard, it adds it up. So now we know that all these values added together gives us 386.6. Okay. So we have been able to get the summation of this. All right. Now, my question will be, why are we doing this? Why are we doing this summation? Now, here is the formula for calculating arithmetic mean. What do you see? X bar equals summation of X. That is, add up all the values in X, divide it by N. This entire formula is called the arithmetic mean. So what we have just done is to add up summation. That's what we did here. Are we following?
Yes, we are.
Okay. So the next thing we need to do is to do the division of this total of summation by N, which is what we have here, S bar 1. So simply do the value here divided by the value here, and we have our mean. So we do equal to. Once you do your equal to, click on this number. It will add the cell number there or the cell reference. Then you do divided by, then you click on 15. It will add the cell reference. Once you press enter on your keyboard, it gives us our mean. So our mean is 25.77333333. So we have gotten the first mean value, X bar, for this first group. Is anybody confused at this stage? Any confusion at this stage? Okay, silence means no confusion. So I can continue, right?
Go ahead.
All right. So our mean now is 25.77333. My task for you, since I have used the first group to illustrate, okay, I think it would be nice if you can try it out for the second group of data. You will also notice that in the document I left for you, let me try to open it. I think I should have opened it and used it to explain some of the things you will see there. Let me just try to open it quickly. This starter point. Okay, so this is where we are. Okay, you notice that I have the same formulas I'm showing you. I've already displayed here for you to see. So where I have summation of X, I typed it out in full letters for you, sum of X. So all you just need to do in each of those instances is to put your cursor here and do the summation. And here you have mean of, as in mean, that is where I have X bar in my screen, I have represented it by U. So you have U as your mean. It's just a label to represent mean. So where you see X bar on my screen, just know that we're talking about mean, which is U1. Now I want you to follow the same approach to do for the second group. What is the mean value that we should get here? Can somebody quickly do that? What mean value should we have here? And then what should be the value for our summation of X? Please try it.
Our mean is 311.9. While
Go ahead, please.
While our X bar is 20.793.
Okay. So hold that value. Everyone, please hold the value she just mentioned by your left hand. 311.9 and then 20 point some values. That's the mean. Now let's go ahead and solve for the mean of the second group. Okay, let's solve for the mean of the second group. So for the summation of X, we simply do equals to sum, and then we drag down. Now remember, in the exam hall, we don't have Excel to our.
Sorry, excuse me, don't be angry.
No, there's no anger, please.
How did you get this X?
I didn't get your question. Okay. Did you just join now? Maybe you just joined.
Yes, I just joined. Actually, I'm using. Yes, I just joined now. That is the thing.
Okay. So if you just joined, just observe what I'm about to do. That's exactly what I did on this side of the screen to get those values. Do you understand? Okay. So what I'm about to do here at this point is the same thing process I followed to get this value. But just for a quick repeat, the first thing I did was to know the number of items we have here, which is 15. If I double click this, I did equal to count, open bracket, clicked on this first value, dragged down. As you can see, I clicked on the first value, dragged down to the last, and it gave me this. I closed the bracket, hit enter on my keyboard, it gave me 15. Then I tried to find out the addition of these values together, what will it give me? If I double click on this, you see I did equal to SUM, open bracket, click on the vet value, drag down to the last, and then close the bracket, hit my enter, and it gave me this value as the addition of all these values. Now for the mean, we said the mean of our evaluation is this formula, which is this value divided by this value. That is what we did here. I just did equal to, then click on this cell, slash, clicked on this cell, which is equal to this divided by this. Immediately I hit enter, it gave me this value, which is our mean. Okay. So now the next thing I want to do to confirm the value reported by our sister that the summation of these values is 311 point something and the mean is 20 point something. We'll quickly do that. Repeat the same process we just did here. Click on this place, do equal to SUM, and then click on the first item, drag down to the last one, close the bracket, hit enter. Kudos. She got it right. All right, she got it right. And then to get the mean value now, what we just need to do is to say equal to, we click on this first value, say divided by. Since we have the same number of items here, which is 15, we just say divided by, we click on 15. And once you say enter, we have 20.79333. So congratulations to you, sister. You did well. So we are at the same point now. And if you follow these simple steps, we have been able to calculate our arithmetic mean. Now, the implication is that we have solved these two numerator labels in this T formula, because now we have our X bar 2 and S bar 1. To get our variance, we need to expand our table. So we need to evaluate deviation from mean, or mean deviation from our observed value, which is this. That is our X value minus our mean. X value minus our mean is known as deviation. It's known as deviation. That is why I intentionally placed this D here. It's known as deviation. So what do? You simply do to automate the process. Now, let me pause and say this. Remember that I wanted to say it before I was cut short before now. Remember that in the exam, we don't have Excel to our rescue. In the exam, you actually have to use your calculator to do this 26.1 plus 26.9 plus 25.3 until you add up all this to arrive at this. And then you just count 1, 2, 3, 4, 5, 6 to the last one to know that it is 15. And as you are doing that, you are writing on your paper, and eventually you will now do this value divided by this value to get our mean. Okay? Then we'll begin to do our deviation from mean by saying the value 26.1 minus this value 25.77333333, whatever it is, whatever the value of that subtraction we get on our calculator, we record on this row for that number. But here we are using Excel. Excel will automate it for us. We just evaluate for the first one, and then Excel will automate the rest for us. Okay. So what we are going to do now is to say equal to. Whenever you're running an evaluation in Excel, you begin with equal to. So what are we evaluating? Equal to, we click on this value and we say minus this value. So we're saying 26.1 minus 25.777. Please don't click enter yet on your keyboard. Don't press enter yet, because we need to lock this cell so that it doesn't increment itself. Once we do the automation we want to do now, if we don't lock this cell number, it will keep on incrementing itself. So instead of having the same cell number referenced here, this cell number is D21. If you don't lock it in Excel, once it gets to this row, it will look for D22, D23, D24. Do you understand? Do you understand me, please?
Yes, go on.
Yeah.
Okay. Okay, so now we need to lock that cell so that it remains D21 throughout the execution of this, the rest of this. So simply bring your cursor in between D and 21 and click your $sign and enter your $sign. That will lock that cell. So if I press enter now, 26. Please mute your mic. Okay. So now the deviation is 0.32667. Okay. So to automate the rest, simply place your cursor at the lower end corner of this cell. Once you click on this cell, place your cursor. You see the shape of this cursor right now is bold cross. But once you carefully place it here, you see that it's a tiny black cross. Do the same and double click. And Excel automatically fills up the rest for us. So what we have simply done is 26.9 minus 25.77 to give us this, 25.3 minus this to give us this, 23.7 minus this to give us this. Okay, now let's validate that what I've said initially about locking this cell, if it is correct. Pick any cell of choice, double click into it. If I double click into this one, you see that we still have our D21 marked. You can see it marked. So we were able to successfully lock that cell. So what we are doing in each of these is these values minus this, and we have these entries. So this is deviation from mean that we have just calculated. In the class, all you do is to press your calculator, 26.1 minus the value of your mean. Whatever value it gives you, you key it in here. Okay? And then you do this, repeat the same process for each of the other numbers. And once you have successfully done that, you have done your valuation deviation from mean. Then we need to do the square of that deviation from mean to get our variance. Okay? So let me show you the formula for variance, which is already on your screen. You're seeing it. I just masked it here. You see that our formula for variance is summation. That is, add up all the values for the square of deviation from mean. Let me unmask this now. Okay. So you see that what we have here is x minus x bar raised to the power of 2, which is the same thing we have here, which is simply to square this value. This value squared will give us what that is. What you have in bracket is simply what we have here before, okay? And we're just squaring it. So if we square it, the summation sign in front, which I have explained before, is just to add up everything that occurs in this column. And then we have that value, okay? So now, let's do the squaring. You just do equal to, click on this cell, and then do caret 2. On your keyboard, locate your caret sign. Shift on my keyboard, it is Shift 6 to type the caret. Shift 6. It should be Shift 6 on your keyboard if your keyboard setting is same as mine. But if you don't find it at Shift 6, then you need to press different symbols on your keyboard to locate the caret sign. So this is this value squared. Once I press enter, we have this value, 0.1067111. At this point, you repeat the same thing we did before by placing your cursor below this and double clicking, and it fills up the rest for us. And we have been able to solve this top part of variance evaluation. Are we together?
Yes.
Okay.
Yes, we are.
So the next thing we need to do is to evaluate our variance, because we already have the top part, and the lower part is simply 15 minus 1, right? So let's go ahead and evaluate our variance. So you see that I have my variance here. Just follow my mouse and you see where I have my variance here. So maybe I just pause a few minutes so that you can repeat what we have done for this second table. That way, I don't need to repeat, speak as you are doing it. You just do it and you get the same thing as what we have done. You already have your mean. Just do the deviation from mean and then square it. I'll keep quiet, do it on my own side while you are doing that. And I think we should all be done by now. Can I go on? Can I continue?
Yes. Go ahead, please.
Okay. So what we are going to do now is simply evaluate for our variance. And you remember, because this is a sample, we're going to be using the sample variance. That is why we have n minus 1. So quickly, simply do this. Oh, okay. There's something we okay, variance, yeah. Variance is just to do the submission of this. So we do sum, then click and drag, press enter. We've been able to get this, the top part of this equation. So we've gotten the top part. Then here we can now finally do our variance, which is equal to deviation squared divided by, because we are doing 15 minus 1, we need to open bracket to tell Excel to evaluate the bracket first. You remember in mathematics, there's what we call board mass. You open bracket first, okay? Then you do multiplication, you do division. Multiplication, the first one is O, which is off, which also stands for multiplication, then division, then M for multiplication again, and then A and S, addition and subtraction. So because of that, we need to tell it to solve the one in bracket first before dividing. So open bracket, and then you say 15 minus 1, close the bracket. Once you hit the enter key, you have 3 points. 3 point what? I need response.
3.5392
And the rest, okay.
38095.
Yeah. Thank you very much. So this is our variance. This is our variance. So please go ahead and solve the variance for the second group. Solve the variance for the second group. And the first person to finish should tell me what the deviation squared and the variance values is supposed to be. And any response? Who has finished?
Of what are using phone?
Wow. Phone. It would have been easier for you if you are using a laptop, you
Yes.
know, but that's fine. At least you are still participating. You know, the important thing in most of these things is to be involved. What we are doing now is registering in our minds, and we can easily remember in exam because we participated. So it's
Yes.
a good thing that we are participating. Okay, so someone should have finished by now. Who has it? If you solve it and your answer is not for variance 12.56352, then cross check. I've given you the answer for this variance. That means you need to get this right so that you're correct. As much as possible, what I want us to do is to solve this question, use our 4-figure table, get our T calculated, make our decision, and then we'll go to XPSS, move this data into SPSS, allow SPSS to do the evaluation, then we'll compare our answers with what SPSS gave us to be sure that we got it right. When we're able to achieve that, we will know that we have really made some good achievement today. Now that I'm even speaking about it, I remember an aspect that I skipped. The first stage in solving t-test is to formulate our null hypothesis, and we did not do that. So start thinking about the null hypothesis for this t-test. Later, I will ask, and then we will formulate one before we finally make our final conclusion. Have we gotten this solved now? I need to move on. Have you gotten it right? Wow, we are
Yes,
quiet.
you've gotten the
Okay,
answer.
the first one is 12.52.
Okay, 12.56 and
Five
zero.
two-
Some okay,
No, 12.5261. Oh, am I wrong?
okay, okay. So what was your deviation from mean? Deviation square.
That's what I'm saying now. Okay, oh, okay. Hold on.
Yeah.
That was just my deviation. I didn't square it.
Okay.
That won't be.
Okay. So let's remember to always do our deviation square, because it's if you miss it at that point, your answer will be different.
It's actually 1.88 and 3.54.
No. I'm talking about for this second group of data. What you just
For the
mentioned is
second
for this.
group. Okay.
This second
Are you
group,
talking about
I solved this part. I said, please solve this other part. This to get your deviation from mean square and your variance, because I've shown you how to do it using these two. So I just need you to get this so that I can be sure that we are on the same page.
We have gotten the variance now. We have gotten the variance, the 3.54 and 12.56. Right? Okay, sorry.
Squared is 175.88933.
Okay, exactly. That's the number I'm looking for. 175.8893, and then some other numbers. And this value should be what? The variance.
Sorry, what do you mean?
The variance. You've gotten this. What's the variance?
Yeah, the variance is 12.56352.
Okay, so every other person, if you got the numbers that have been read out by our brother, then you're on the right page. Okay, so we have gotten the variance. Now, to get our standard deviation is simply our variance, the square root of our variance. Look at the formula for standard deviation. I think it's time for me to remove this mask completely. The formula for standard deviation is simply putting the square root sign on top of this existing formula that we had before. You can see that, right? Okay. So to do that, we simply come back to our standard deviation value, say equal to, and you do square root SQRT equal to SQRT for square root. Okay, open bracket, click on your variance value, close the bracket, and you have your standard deviation. So the standard deviation is 1.88 and the rest of the digits.
1.88 and 3.54.
Okay, so repeat the same to get your standard deviation on this other side. While you are doing that, I'll fill in the blank on the where I am left out here. So what's our standard deviation for the second group?
3.54.
3.54450. Okay, yeah, you're right. So let me just solve that on my side. Square root. All right. So we will pause here and do some explanation, because I remember some of our class members asked me, this man talks about discussing it. So the problem is, how do we go about the discussion? You know, the discussion lies in your mean and standard deviation. Your mean and standard deviation will help you discuss the value. If you look at the value of this mean and this, are they the same?
No.
Not at
They're not
all.
the same. So group A mean is higher than group B mean. Okay. So that's already giving us some idea that group A members are performing better than group B members. So you're already discussing the value. But then the standard deviation, you see that the standard deviation between the two groups are also different. The group A standard deviation is smaller than the group B standard deviation. And we say that standard deviation tells us how dispersed the variability within the group, how spread out the scores are from the mean. Some of us may be
From the mean, yeah.
confused when, yes, some of us may be confused when we talk about how spread out the values are from the mean. So I did something to illustrate that. I had to plot this data set, plot the mean and standard deviation, so that we can see what it means when we say that it is spread out. You know, to talk about the spread, we are talking about the some of the values are at a point that is 1.8 are above the mean, and some are at a point 1.8 below the mean. So if you add this standard deviation to the mean, that is the location where some of these values are. Now look at this plot. This is the plot of the data for group A, and this is the plot of the data for group B. Okay. Now, the red line here is the point of our mean. Our mean is 25.77. So you see this point is 25. This is 25.77. So close to 26. So this is the location of our mean value. Okay. Now you see this, each of these blue dots are the actual observed values. This first blue dot is this 26.1. The second blue dot is 26.9, which is why you see that they are close by. This is 26.1. You see it's close to 26. This is 26.9, almost close to 27. So these blue dots are the spread of our data. Okay. And this red line is the mean. Now you can see how deviated most of these numbers, dots are from the mean. The green lines are the values of our standard deviation. That is 1.8 distance away from the mean.
Excuse me. Did you use SPSS to do this analysis?
No.
You copied it? Okay.
No. SPSS will not give you this chart. I use Python.
Okay, you use
I use a different
okay.
analytical tool. I intentionally placed this just to illustrate mean and standard deviation and the spread we are talking about, because that will help you to discuss your
Do
results.
the analysis.
Yeah, to discuss the results. You see that you see that these values, most of them are close to the mean. For instance, this point where my mouse is pointing at is close to the mean. In fact, there's a value that is very close to the mean. This one. Can you see that?
This should be chart plots in Python.
Yes, it's plotted in Python. Okay, so you see the spread, the dispersion. When we talk about dispersion, when we're making reference to standard deviation, this is what we mean by dispersion. How spread away from the mean these values are. And you notice that some of them are even so far that they are not within the range of the standard deviation. These 2 points are away from the range of the standard deviation. These other 2 points, these will be considered as outliers. But then you see that these are the people that scored the highest. So most of the people have their scores between 24 and 27 point something. Majority of the people, their score range is between 24 and 27 points, some values, which is this blue green line and this green line. Okay, so you now see that the consistency of the data points around the mean is smaller for the first group. They are closer to the mean. So the consistency is around the mean. The smaller this standard deviation, the more closer these values will be to the mean. But look at the second group. You see that this consistency is way too far away from the mean. This is the mean. It's only these first 4 entries that are close to the mean. This, and that. These are the only the only values that are close to the mean. Others are spread out away from the mean, which is why the standard deviation is this high. Meaning that the consistency within the second group, their scores are not consistent. So people are having very poor scores, as low as 17 point something out of 30, and some others are scoring 29 point something. So the variability is very large. Are we following?
Yes.
I've taken this time to explain this aspect of mean and standard deviation so that you can understand how to interpret it and discuss it. When the standard deviation is high, is large, it shows more dispersion, more spread, that the data is scattered away.
Sorry.
Yeah, go ahead, please.
Please, if there are people that have their microphones on, they should mute them, please. Please, people should mute their microphones so we can hear him clearly, please. Or you, I think you should just mute them. Or anybody whose mic is on, you just take the person out of the call.
Okay, now you can all hear it. If I take you out of the call, please understand that you are disrupting the flow of this discussion. I intentionally left the mics open so that you can ask questions at a point where you are not following. It will not be nice for me to block everyone from responding. So please mute your mic so that we can be on the same page. So what I'm saying is that when your standard deviation is large, it just means that the actual observations are scattered far away from the mean. And a good illustration is these two charts. You see that the standard deviation that is larger, which is 3 point something, if you look at the observations, you see that they are scattered away from the mean. Only these 3 points are closer to the mean. But the smaller standard deviation shows you that the actual numbers are closer to the mean. Their spread is closer to the mean, and you can see that this is more consistent than this. So the smaller your standard deviation, the better. So it would have even been better if this standard deviation is 0 point something. That means these observations will be clustered around the mean, close to the mean, just like this one, this very point that is very near to the mean. So this very one is 0 point something close to the mean. So if this standard deviation is smaller, all these values will be very close to the mean. So when we talk about spread or dispersion from the mean of the standard deviation, these images clearly illustrate it. Do we understand? Please, do you understand?
Yes.
Okay, so with that, you can have an elaborate discussion on your data. So now let's go ahead and finish up with the rest of the analysis. So now we have been able to find our variance, which is this, the S squared from here, and we have all the rest of the labels sorted out. The next thing we need to do I took time to do this bit by bit. It's just to carry everybody along. Is to do this, our mean of the first group minus the mean of the second group, which is what we have here. Okay, so you simply do equal to this minus this, and you should have 4.98 as your answer. If your answer is not 4.98, then you're wrong. Please note that this call is recorded. So if by any chance you miss any part of the discussion, at the end of this call, I will attach a document that has the link to the video in the same folder where you've got other resource materials, and you can be able to rewatch and follow through. So by getting this 4.98, we have solved for this numerator, right? So the next thing we need to solve is each of these values. Okay? So can somebody solve for this? It's simple enough. It's just our variance divided by what? Our n. This divided by this for this first one. And then this divided by this for this second one. That's simple enough for us to get. Okay? Let me go ahead and do it, which is equal to, here's our variance for the first one. This is the variance. And then divided by our n, 15. And that gives us 0.235949. We repeat the same thing for the second one. Our variance divided by 15. And that gives us 0.837568. If your answer is not the same as this, then check, you may be making a mistake. And finally, we now have to evaluate our what? Our t, which is simply the top value, which is this. We have solved everything. The top value divided by the square root of the second value, of the lower value. And that makes our work much easier. So the top value, what do we have? This value, 4.98. Then we say divided by. What are we dividing by? Somebody should please respond. Are we still on this call?
0.0.235949.
No. That's not what you're divided by. I just mentioned it.
0.235949.
In your look at this formula. We are dividing by the denominator.
The square root. The square
We are
root.
dividing by the square root.
The square root
Okay,
of this
the
value
square root of that.
plus this value. Yes.
Yes,
The square root of this value
Okay.
plus this value. Okay.
Open bracket.
So you don't even need to open bracket at this point. You can just simply call the square root function by saying sqrt, which is square root, and then you click on the first value plus the second
Divided
value
by.
and close. You don't need to do divide again. If this one divided by square root of this plus this. Okay. And once you hit enter now, you have your t calculated. Once you hit enter now, you will have your t calculated. So what's our t calculated?
125.
What? What did you say, please? What's the value for our t calculated? Are we together?
0.
Hello, someone is here. Oh. Please respond. You should have gotten it by now. No one is responding. Everywhere is quiet.
4.806455.
Exactly. Thank you very much. 4.8064.
806,455.
Okay. So that's our T calculated. So we have finally solved this. You'll notice that we took it bit by bit. Once you see this question, I definitely this question is going to come out, I'm sure. So just use the same process we have used now to solve the actual question. Remember, this question we solved is I formulated it in the pattern of the original question. So you just follow this process step by step to solve the actual question that we have. So with this, we have gotten our T calculated. So it's time for us to go to our T table to make a decision. Now, before we go to our T table, what is our null hypothesis? Someone should please formulate a null hypothesis. Let me I'll call a name. I'll call somebody that I know very well. I'm going to call somebody that I know very well. The first name that came to sight was Bernard, but Bernard, I'm pitying you. Should I call you? Okay, Uche Wampa Princess. Please formulate our null hypothesis. Princess. Princess is not in class. She registered and went somewhere else. Okay, let me look for an gifted. I've not heard your voice today. I think I know this gifted. Gifted can.
Hey, I did.
Everybody is quiet. You did. Thank you very much. Oh, yeah, what's up? What's our null hypothesis for this test that we are doing? Law. Get ready to.
No.
Okay. Gifted. Gifted. What's the null hypothesis? Okay. Who wants to help out? Who wants to help out, please?
If the T calculated is greater than the T tabulated, reject the null hypothesis or what?
Yes, that's the decision rule. But what is our null hypothesis?
Well, I
Remember,
thought we're
the
supposed to
question
do
said
the T tabulated before we now have our null hypothesis.
no. You construct the null hypothesis first. Look at the question. The question says, in the question, it says construct a suitable null hypothesis and use it and use the t-test to test that null hypothesis. So the first stage is to construct a null hypothesis before you even begin to solve the question. Yeah, try, please.
You can't remove the question.
Oh. Sorry. Okay. So what is our null hypothesis?
Okay, there is no significant relationship. There is no statistical significant relationship between
Go ahead, please. You're on the right path. Go ahead, please.
we are covering the question. I'm looking at the question.
Oh, okay.
There is no
Can you see it now?
statistical, significant the relationship between the performance score of the two groups of pupils.
Okay, you got it to some extent, but you missed it to some extent. Who wants to rescue her?
There's no significant.
Sorry, I want to ask, what is the T calculated and T tabulated that we just got? I want to know, please. Sorry.
We have not done tabulated. We are still on calculated.
We have not done tabulated. We have just gotten the T calculated, which is this. But before we go to the table, this is the value. I'm pointing at it.
Okay, this is the T calculated, right?
This is T calculated, yes.
Tabulated,
so,
not calculated.
Calculated. We calculated it now. Did we not calculate it together? We calculated it. We have not gone to the table. Okay. Okay, so let's formulate our null hypothesis, because it's the null hypothesis that we're making a decision against once we check our table. So who wants to help Esther? Esther, you tried. Okay, when you do a t-test, what are you checking? The difference in what?
The two groups, right?
Yes. The difference between the scores of two groups. So,
of two groups, yeah.
Yes, formulate the null now so that we can make our decision. We are done with the calculation. At least at this point, we are done with the calculation in class. So, which null hypothesis did you formulate? Remember that you will get a score for formulating the null hypothesis. So, which null hypothesis did you formulate that you are making a decision against now?
No statistically. There is no statistical relationship between the performance of the two groups.
Not relationship. You people are using relationship. Relationship is for chi-square or correlation. So you're mixing it up.
There's no statistical. There's no statistical
difference.
Difference, yes.
Between the performance
there's no significant.
There's no significant difference.
Okay. Between what?
The performance of the two groups.
Between the two groups.
No.
Between the two groups.
The what of the two groups? The sum.
The score.
The score, yes, the score. But what? There's something you are missing. Even on the last Sunday, Prof Steve corrected it. There's something you are missing.
The mean.
Exactly, the mean score. Okay, I maxed it. It's
okay,
here.
Please, can you rephrase the hypothesis for us, please?
Yes, this is the hypothesis. Null hypothesis. There's no significant difference. There's no significant difference between the mean score of group A and group B.
Hello?
Please come again.
You can see it. It is, I've unmasked it. It is written there on the screen. There is no significant difference. You can say there's no statistically significant difference between the mean score. Okay, mean score. Remember, here we're talking about score of pupils. In the actual something, it is performance. Okay, so you say mean performance of group A and B.
Okay, hello, can I say something?
Yes, I can see digital EasyTech. EasyTech, please ask your question. EasyTech.
Hello?
It's not ready. EasyTech is not ready. Oluwakemi, what's your question?
Sorry.
Okay, you're ready now. Yes.
Just
there's noise in the background.
Can you hear me?
Yes, I can hear you.
Okay, just go ahead. I'll ask my question later.
Okay, Oluwakemi, show me.
Okay, yes. Thank you for your patience and everything. But I have a question. This null hypothesis that you formulated now,
Yes.
What value did you use to conclude that there is no significant difference between the mean? Is it the 311.9 and the 386.6? Is that what you used to to conclude to reach that null hypothesis? I really don't understand that part.
Okay, so now this is thank you for this is a very important question because many of us would please let's mute our mic so that as I explain people can understand. Many of us would have made the same as error. Now, when you're evaluating Kemi, can you please mute your mic?
Okay.
Kemi,
all right.
Yes, please.
Yeah.
Okay, so now when you are evaluating t-test, the first thing you do is to formulate a null hypothesis, or even anytime you're doing any form of inferential statistics, regression, correlation, analysis of variance, the first thing you do is to formulate a null hypothesis. Okay? And now we have two groups. You are saying that you don't think there will be any difference between the scores of these two groups, that their score is going to be the same. That's what you are assuming, because you know that these two groups have smart people in them. So your null hypothesis is saying these two groups, their score is the same. There's no significant difference in their score. That's the null hypothesis. That's what this is saying. You formulate this null before you even do the calculation or the evaluations, so that your t-test will now tell you if this null is true. You are either going to reject the null or you fail to reject the null. Okay? But the mistake I made was that I forgot to call us to attention to formulate our null before we did our evaluation. So because we have finished our evaluation, you got a bit confused about that. So we are supposed to formulate the null. That is why the question says construct a suitable null hypothesis. So the first answer to this question is this: there is no significant difference. T-test is checking if there's a difference in performance of two groups. And at first, you begin by saying not guilty. There is no difference. Their scores are perfect because you trust that they should perform well. So you believe that there's no difference in there will not be difference in their scores. So if you say there will be no significant difference, you are still right because you have not tested it. So now we have said that there will not be significant difference in the mean score between this group. We are giving them the benefit of doubt that they will all perform well. So there will not be difference in their mean score. That's our null. Now we will go and solve do our analysis.
Hello?
Hold on, I'm coming. Hold on, I'm coming, please. Now we will go and do our analysis and find our t. This t value will now tell us if our assumption by the way of the null is true or not. All right. Allah.2, please ask your question. Mr. Isaac.
Hello, can you hear me?
Yes, we can hear you.
Okay. All right. What I want to say is not 100% a question. It's just a contribution.
Okay.
Actually, virtually everybody's confusion is my confusion as well. And I find a way to look for answer to it. It has to do with formulating the null hypothesis question.
Yes.
So when I look on the null hypothesis question, it's more or less like whatever we are asked to do is the way it is. That's what null hypothesis is all about. That nothing happened. Everything remain status quo. Please, can you help me to show the question, please? You know, there are some technical terms that has been used from time to time that confuse people further. The statement is the performance score for two groups of pupils are given below. You are required to compare average score for the two groups of pupils. That's what we are asked to do. So your null hypothesis is nothing happened. There's no, as in everything, comparing the two, everything remain as is. There's no effect. So
meaning that there's no difference. Their scores are meant to be perfect. You assume that the two groups are going to perform well.
Yes.
But then
The
you now
average
use
score.
the t-test. Yes.
To now test if the average score, that average is what they mean by mean score. Mean and average.
Yes,
means the same thing.
Exactly.
So it's very simple and straightforward. It simply means what they state in the question is correct. So if it is correct, the null hypothesis is right, then we accept it. But if it's not, then we reject it. I don't know if I'm correct. That's where my question is.
You're right. So when you have a t-test comparing two groups, the first thing is to consider those two groups, give them 100% chance of success. You say that they will all perform well. And we clap for them, yay, they will perform well. So we're saying there is no difference in their scores. The group A is going to score 100%, group B is going to score 100%. That's what the null hypothesis is checking. Now you need to put it under statistical watch to see if truly they will all perform well and there will not be difference in their scores, which is why we have done the t-test. Somebody have been trying to come in. Her network is not just allowing. Okay, we have done the t-test and we have a t-value that will help us confirm. If you notice, when we calculated the mean, you see that there's a difference in this mean. This is 25 point something, this is 20 point something. But is this difference, is it statistically significant? That's what we want to check now. So we will call up our t-table. Remember, our mean value is 4 points. Our t-value is 4.806 and the rest. Okay, so let me just bring up the t-table. Where do I have it? And we will make our decision. Okay, this is the t-table coming up. Remember also that the question said at 95% confidence interval. At 95% confidence interval. How many of us remember how to read the t-table? I'll allow somebody in this call to read the t-table and tell us where we should be pointing at. Just guide me. So what's the first thing we're supposed to do? What's the first thing
we can use
I think we were
Our
supposed to do
95% falls under
degree of freedom first.
0.05.
Yes. Degree of freedom is the first thing we pay attention to. So what is our degree of freedom?
Okay.
What is our degree of freedom?
It will be 2.5. 2.571.
Are you sure? Are you sure? Our degree of freedom,
Yes.
are you sure? How did you get your degree of freedom to be 2.571?
You take it from 5 because it's actually
No.
higher than 4.
No. Hold on, sir. We're talking about degree.
5.
No. We're talking about degree of freedom now.
I think.
Okay.
It's supposed
I
to be
intentionally left
NA
that side.
minus NB.
You said something now.
N for the group A minus N of group B.
You're close to it, but you didn't get it. That should be N of group A plus N of group B minus
2.
Minus 2. Yes. N of group A plus N of group B. So that would be summation of NA, as in that should be 15 plus 15, right?
So that's 28.
That's to be 28.
28.
Sorry, how do you arrive at the 28? Can you? Was that
15 plus 15 minus 2.
Okay, correct.
You get.
Oh,
so are we on the same page now?
Oh.
All right. So
Okay.
Our degree of freedom is what? is 28.
28. Yeah.
Okay. At 95% confidence interval, where would that be?
That's
That would be
2.0.
48.
2.04648.
Yes, 2.048 is our T tabulated.
Tabulated.
Yes. So what's our decision now? Are we rejecting or we are failing to reject?
We are rejecting.
Let me do like Professor Babalola. Let's go on this 1, 2.
When T calculated is greater
T
than
calculated is higher than the T tabulated.
We
reject
reject.
null hypothesis.
Yes, exactly. Reject null hypothesis.
When T calculated is higher than T tabulated, reject the null hypothesis. Okay.
So this our T calculated, is it higher than T tabulated?
Yes.
Yes.
Okay.
Yes.
So we are rejecting the null. That is, we are saying that there is a statistically significant difference. We have evidence to believe that there is statistically significant difference between the mean performance of group A and the mean performance of group B. Is anybody confused at this point?
No.
No.
Okay. So that is the point. So we have been able to solve this. And when we get to class for the mid-semester and this question comes up, I'm sure it will probably come up, something related to it. Be confident to take it. You can solve it. We can all solve this. We can. Okay. So now, how sure are we that our evaluation is actually correct? I want to quickly run through SPSS. I'll take us to SPSS and run through this analysis on SPSS. If SPSS gives us the same T value as we have calculated, you can be sure that our process, our flow of solving this is accurate. Are you with me on that? Can I go over to SPSS now? Okay. So I'm going over to SPSS. I have a blank field here. So all I'm going to do is to define the two groups. On the variable view, time is almost up. So I'm going to be running through the process very quickly. I'm actually practically still in the office. My family have not seen me since morning. So, and where I live is far from work. I need to close early to go home in safety. Okay, so let me just quickly go through this. So I have a blank SPSS view. Can you all see my screen?
Yes.
Okay. So I'll first of all go to my variable view to define the properties of this data. So I'll quickly just say group A here. Group A. And then I'll come here and say group B. No. That is not how you prepare it in SPSS. I forgot something. Okay. Now, in SPSS, to do this in SPSS, all we need is two variables. Groups and scores.
Group A and group B.
No, not group A and group B. Groups and scores. So we have groups. The first one is groups. This is where we define all our group items. And then the second one, which is our dependent variable, is scores. Sorry. Am I typing so wrong? Okay, scores. So let's go back to variable view. I mean data view. Somebody please mute your mic. Who is that? For justice. For justice, mute your mic. Okay. So all the scores we will put together on one side, and all the groups. So for group A, let me go back to variable view so that we can define our groups. Under the values, we will define our groups. For group A, we assign them the value of 1. So here we can now say group A. and then we add. And then for group B, we are assigning the value of 2. And then we say group B. And then we add. We have defined these values. And that's all we need to do here. So I will go back to this, copy the values for group A. Copy, bring it in here into scores. Okay, I made it into 0 decimal places. Let me make it into 1 so that the decimal points are showing. Into scores. What value did we give to group A in our variable view? What label did you give it?
1.
1.
1.
So all you just need to do is to do 1, 1, 1 for all group A, because what we just copied now is group A. We give it 1. Then we go back to our data and we copy the values for group B. And we paste it here. All right. And then we'll assign it the value 2 because we gave it 2. Okay. And we are done with this. Now, if you are with me on SPSS, if you click on this symbol, you see that it will show you group A and group B. Those are the labels we initially defined here. So they are just nominal labels. So we now have group A and group B. So we can now go ahead and carry out, let me just define the measures here, nominal and scale, so that it's well represented. So with this, we can now do our t-test by simply going to analyze. Are you following? Are we still following?
Yes. Yeah.
Okay, analyze, compare, independent sample t-test. Remember that these two groups are independent of each other. That's why it is independent sample t-test. You click on it, this box appears. You take the score and bring it into the test variable. Okay, then you take the group, click on the group and bring it into grouping variable. It will give you this question mark saying define the groups. I don't know what these groups are. Then you go in and define group 1 is 1, group 2 is 2, which is the same labels we already assigned to them, that is 1 and 2. Click OK and click OK, and SPSS will populate the result in the data, the output view. Okay. Remember, what we are trying to verify is our calculated T. Are we together?
Yes.
Are we still together? So what we are trying to verify is our calculated T, to be sure that we got it right. All this calculation we've been doing since, I hope we did not miss something. So this is the value we are trying to verify. So if we go back to our SPSS output view now, this is our calculated T. Is it the same?
Yes.
Yeah. So we got it right. Our flow was 100% correct. Okay. So we can pat ourselves at the back to say that we have done well. Implication is, if you follow this procedure that we have used to solve this question in the exam hall or wherever you encounter it, you will be right. Just remember the flow. Don't be afraid of the formula. Remember the flow, and we got it right. So we have successfully solved this, and we have spent, for some of us came in very early, people like Esther. Esther came in very early. Some of us that came in very early, we have already spent 2 hours. But counting from 6:30 that we're supposed to start, we just have about 6 minutes, and it will be 2 hours that we've spent solving this. Yes, Mr. Oladotu. Go ahead, ask your question.
Can you hear me?
Yes, we can hear you.
All right. I made a comment concerning the null hypothesis earlier.
Yes.
But in a situation whereby t tabulated equals to t calculated, what happened?
I don't think it can ever be the same. That would be a very rare case.
That is question number one. Question number
Situation
two,
where
t tabulated equals t calculated.
Are we not going to do the formula?
I'm sorry. I'm not sure I got your question. Something
My
interrupted
question
my network.
Okay. In a situation
Yeah, so
whereby
I got
in a situation whereby t tabulated equals to t calculated,
yes.
what happened? What happened? That's my question number one. And question number two is, can one get the hypothesis question wrong?
Formulating your hypothesis, can you get it wrong?
Yes. Is it possible?
Yes, you can get it wrong. If, for instance, you're doing a t-test and you say there's no significant relationship for a t-test, you have gotten it wrong. Remember, some of us were already saying relationship before. You need to understand the test you are doing, what it is checking, so that you can be able to formulate the hypothesis the right way. Okay. Let me give you an instance. If you're doing a regression analysis, regression is checking for effect or impact.
Okay.
So you say something like temperature does not have any significant impact on maybe something else or effect. If you're doing t-test, you're checking for difference in values. So there's no significant difference. If you're checking for chi-square, association or correlation, relationship, there's no significant relationship. So it's possible to get it wrong if you don't understand the test you're evaluating. And then to your second question, which is a very interesting question. It's in my several years of working with data analytics, that question I've never asked that question. I've never occurred to me. So I think I will need to research that because I've never encountered it where your T calculated will be exactly the same as your T tabulated. It's very rare. It's very rare. Okay. But I've never even considered it before. So it's something I will need to research, to ask questions, to know if anything can like that. And when it happens, what decisions do we make? Because T calculated is the same thing as T tabulated. So you are at a boundary. You don't know whether to reject or to accept, but it will be highly rare. If at all it's going to be the same, there will be a decimal value that will differentiate it. It cannot, it will not, it may not, let me not be assertive on this. It may not be 100% the same. Are you following? So if we have something like 0. Or okay, let's use our evaluation. We have 4.806, and the T tabulated is 4.807. One is already higher than the other, but then at the same time, the p-value will help. The p-value will help. Most of the time when we are doing data analysis, we are not doing it manually like we have done it with Excel. Most of the time you are using a tool like SPSS or some other analytical tools. So p-value will help you in that instance. Because at 95% confidence interval, you're saying that your p-value is 0.05. So where your p-value is less than 0.05, you reject the null. And if you look at our p-value in this output, SPSS output records p-value as sig. So this is the rule for our p-value. If you look at this p-value, it's saying 0.00000. And you remember Prof mentioned it in class. This is 0.0000 some value, but those values are too distant. If I double click on this, you will see, where is it? You see, this is 0.000047. So the zeros are so much, it will just limit it to 4 figures. Okay, 0.000. Okay, so the p-value will help you in making a decision if the t is very close to each other. If you look at the p-value, once the p-value is greater than 0.505, then you know that you are supposed to reject the null. Is that clear, please? Did you understand that?
Yes. Yeah. Hello, can you hear me?
Okay.
Can you repeat again?
Yes.
Please, can you
Yes, I
repeat
can hear you.
that statement? Can you repeat?
Oh, okay.
T values.
So what I said is this, that it is a very rare situation for the t calculated to be exact the same value as the t tabulated. It is very rare. In my several years of working as a data analyst, I've not encountered it. And that question that you asked, very important question, have never occurred to me. But, random chance, it may just happen. Okay. But it will be very rare. But even when it happens, there will be something that will differentiate the two. And I used this t calculated as an example. Take, for instance, that our t calculated is 4.806 and the t tabulated is 4.806. There will be another value that makes the difference. This is 4.806 454, exactly the value we even evaluated. Okay, but there will be some decimal number that will be different. The t tabulated may be 4.806551 whatever. So there will be some minute difference. But at that point, definitely you're going to either reject. But then to help you make that decision, you look at the p-value column of your evaluation, because most times you will not do this evaluation manually where you have to check your t table. Most times you are using softwares like SPSS or some other data analytics softwares. So just look at your p-value. The p-value will help you support the decision you will make based on the t. If the p-value at 95% confidence interval, looking at this output, you see that here you have 95% confidence interval. That is, your p-value, your alpha is 0.05. So if your p-value is less than 0.05, you reject the null hypothesis. Is that clear, please?
Yes. Thank you.
Okay. And I hope we all do understand that explanation. Okay, thank you. So our 2 hours time slot is exhausted. We will meet again on Thursday by God's grace. And on Thursday we will treat. Are we together? Please, let's be together.
Yes.
Okay, yeah.
On Thursday we will treat this question, the chi-square question. Using what we have done today, you can solve for mean, you can solve for standard deviation, you can solve for many variance and the rest, this statistic and the rest. In the next one, we'll look for how to solve for this one, and then we will decide where to move on from there. I hope we're okay with that. That should be on Thursday.
Yes.
Okay.
Thank you very
much.
Yeah.
So please, I'd like to crave your, please, I'd like to crave your indulgence to make a few comments, and then we'll call it a day. Can I go ahead?
Okay.
Yes.
Yeah, I just want to make a few comments, then we'll call it a day. Can I go ahead, please?
Yeah.
All right.
Go ahead. You can.
On the, how will I put it now? On the softer landing part of it, all I just want to do is to market myself. Don't mind me. My full name is Ekoma E. Agu, and I'm a certified data analyst. I've been in this profession for 14 years now. And yes, I've been in it for 14 years. I'm Google certified data analyst. My field of expertise is in data science. Okay, so the implication is those of us that are in IRM, education, economics, biz admin.
Okay.
Once we get to the point of project writing and you are in need of is an experienced professional in data analytics, you are in good hands. Or you have friends who are at that stage at this moment, feel free to share my contact with them. You get professional services, and to support that, in this column, in this sheet where I say testimonies, these are two excerpts of testimonies that some of the people that I have serviced have about me. You can read. This one on the left is a recent job. Somebody that just finished. No, that's Sharon. Sharon Yu. It's a recent job, a PhD thesis that I analyzed, and she's so excited. She went online to my online profile to drop this, and then this other one is from another client. So I'll feel free to. And those of you that are in the industry, that's true. Those of you that are in the industry, you work in those big companies. I do analysis for industry level clients too. So it's not just research focused. At industry level, I also do analysis. If your company is looking for a capable data analyst to draw insights from your data, so feel free to reach out to me and we'll take it off from there. You can look up my name on LinkedIn and we can become friends on LinkedIn and we can continue communicating from there. Here is the format of my name on LinkedIn. So if you're looking for me on LinkedIn, that's how you locate me, Ekoma E. Agu. Thank you so much. It's been a wonderful meeting with you all, and I pray God will help us all to pass these exams that are coming. But please don't be scared. We can all do it.
Thank you so much.
Thank you.
I also want to.
Yeah.
Thank you so much, sir.
I also want to ask. Can I quickly ask you a question?
Yes, go ahead, please.
Did you study statistics before you went into data analytics?
No, I did computer science, but data analytics have always been a passion for me. In fact, I've been doing data analytics even before I started school. It's always been a passion for me. So I just grew in it over the years, for the past 14 years.
Oh, nice.
Yeah.
Nice.
Wow.
So right now,
thank you so much.
It's a data science, artificial intelligence, anything data, just there's this passion that it gives me, anything data.
Okay. That is good. That is good to know.
And my computer friends, those of us that are in computer science, if you have issues with programming, Python, especially R, W, Power BI, those are all the tools I use. SPSS, Starter, eView, any tool that enables analytics, I use them. So what I just do is when I have a data set I need to analyze, I look at the problem statement and then decide which tool will serve me better in analyzing it. Excel itself is a very good tool for data analysis too. So it depends on the problem statement. Then I decide which tool to use.
Okay. Thank you.
Thank you so much, everyone. We'll meet again on Thursday.
Thank you.
All right. Thank you, Ekoma,
Thank
and
you.
on behalf of the class.
Safe journey home.
Hello.
Thank you.
All right.
Yes, go
So
ahead.
we appreciate your gesture. So while we await you for the next class, so Dr. I appeal to you to we need to do something, at least to appease the gods. Thank you so much.
Thank you very much. God bless
Thank
you.
you. Thank you. Yeah.
So we'll meet again on Thursday. And please remember, I
Yep.
will drop the recording of this in the same Google Drive folder so that you can rewatch and catch up wherever you missed.
Thank you so much.
Yeah.